Uh, Hi, good afternoon, everyone. Okay, so today I'm going to taking your classes. Okay, so just let me know whether you have completed introduction of this chapter. So this is your for chemical kinetics. This is your first class or second class. So like whether yesterday Subham sir has taken your classes, yes or no? Anyone can please write in the chat. Hello. Hello, Jane Ludhiana, can you tell me whether it's a first, whether we are starting this chapter chemical kinetics or this is your second class for this chapter? Am I audible, like audible to everyone? Hello. So this is your second class, right? So okay, let me change the slide in that case. Just wait. Just wait, huh? Because I have two PPT now, so there is some confusion. Just wait a minute. Okay, now just let me know if the screen is visible to you or not. Just let me know if the screen is visible or not. Anyone just let me know. Okay. So sorry, I got late. Okay, and we could not start the class right time. Okay, so don't worry. We can continue now nicely. Okay, and I hope everyone I audible. Okay, so in between, suppose you have any doubt, okay, just let me know. You can write in the chat. Okay, so that we can discuss according to that one. Okay, so let's start. So I hope last class we have discussed some basic of this chemical kinetics. From there we will continue. ठीक ना? So before continuing class, just let me introduce myself. Okay, myself Lachu Naik. Okay, myself Lachu Naik. Okay, and I am from Odisha, and I am now currently working in JNB Mysore, Karnataka. ठीक ना? So this is my short introduction. Okay, and if I add to tomorrow also, like next class also I'm taking classes, so we can have this conversation. Okay, so now let's continue with the class. Okay, so before continuing, so let's understand how much you have studied. इको हो रहा है क्या? Just wait. ठीक है, मैं थोड़ा वो दरवाजा लगा देता हूँ. Now Shailendra Sharma, like whether it is again echoing or not, or now it's just fine, just let me know. Not clear. Now is it clear? Or again same issue, Shailendra, am I audible? Or same problem, like I am not audible that much? I hope it is audible to everyone. Just let me know. Echo. So just let me know whether echo is from all the center or it is only for Shailendra. Like any other center, do my voice is echoing, or it is only for Shailendra? Hello, now it is same echoing. Hello. We have many ways na, like Zendi, Mandi, Simla, echo. Oh, yeah, what we have to do? I hope it is just wait na. Like it is not echoing, so we just wait in that case. Okay, thank you. Okay, so please everyone try to solve this one. Okay, and you can, like some of you can write me in this chat. Okay, what is the answer for this one? We can solve this simple question from the last concept. After that, we'll continue. Please everyone do this. Okay, try to solve this one, everyone, please. Okay, like even if you're not writing in the chat, let's solve this. Okay, so that while I'm solving this one, so you have some idea like what is going on. Okay, na? So please try this. So I'm giving you some time. After that, I will solve this. Okay, na? So I hope everyone you are solving this, right? Okay. Okay, so let solve this one. This is a basic one. I hope everyone you are solving this. Okay, so let me read this question for you first. In a reaction in which we have 2A give us some product, the concentration of A decreasing from 0.05 mole per liter to 0.4 mole per liter in 10 minutes. Calculate rate of the reaction during this interval. Okay, rate of the reaction. Okay, it is not like what is the consumption rate of A. It is overall what is the rate of the reaction. We know this. If we denote this rate by R, then we can write. Okay, so before that one, let me write this one. So here 2A, which give us some product, let's P. So for this one, we can write rate of this reaction is a rate of change of A with respect to time divided by the coefficient. Here coefficient is 2, and we can write same for the product because we don't need product here, so we are continuing with the reactant, that is A. So initially concentration of A was 0.05 mole per liter, and that is changed into 0.4 mole per liter in 10 minutes. Okay, so because this is our reactant and we know this, with reactant we are putting minus sign here, so that rate will go positive. Okay, so I mean this one. So let's put minus half. After that, what is the change of A? Okay, so whenever we are writing change, that is final minus initial. So final we have 0.4 minus 0.5. Okay, this is the change of A. And what is the time? Change in time in 0 to 10 minutes. So we can write direct 10 minutes. Okay, 10 minutes. So here we can write minus 1/2 multiply minus 0.1 per 10 minute. Okay, so we can write this one minus plus, so we can write 1/10 20 mole per liter per minute. Okay, so let's keep it only minute only. Okay, per minute. So see 0.1, sorry, 0.1. So multiply divided by 5. Okay, so this is 0.5 by 100. Okay, so this is mole per liter per minute, sorry, per minute. Okay, so this can be written 5 multiply 10 to the power minus 3 mole per liter per minute. Okay, if you wish, you can write this in the second also. Okay, but if you're writing this rate of the reaction with respect to in the term of minute, you can take anyone like hour, minute, anything. Okay, but here we are solving in the term of minute only. Okay, so the rate, if we donate this rate with R, so we can say rate of this reaction with respect to A is 5 multiplied 10 to the minus 3 mole per liter per minute. Everyone you understood this one, or do you have any doubt? Just let me know. ये सभी को समझ में आया कि shall I repeat this one? I hope everyone understood this. Everyone just let me know. कोई yes no अगर कुछ कर दो, so that I can have clear idea like whether you understood this or not. Okay, thank you Udhampur. Okay. Okay, so I hope everyone you understood. Or do you have any doubt? Just let me know. Like we can discuss this. This simple concept from the previous class. Okay. So shall we continue then? ठीक है, चलो हम कंटिन्यू करते हैं आगे का कॉन्सेप्ट. ठीक है. So today we are going to discuss. So like what are the thing last class we have discussed? उसको थोड़ा सा हम briefly देख लेते हैं. After that we will continue with the today's class. Okay, so last class we have discussed about rate of the reaction, and that too average rate of the reaction, instant rate of the reaction. You know this average means total change by total time. This is average. Instant means at particular time what is the change. Okay, and we have solved them by using this graph also. Okay, we have seen this one. So mathematically, this is for a reactant that is a with minus sign here, and this is a product that is a we have plus sign here. Because in reactant concentration is decreasing, that is a minus sign. Okay, in product concentration increases, in the product is positive, like positive change we can say. Okay, now. So if we want to write mathematically or not mathematically, okay, suppose we want to write, suppose we have a reaction and how to write that one. So rate of the reaction with respect to reactant, we can write rate of disappearance of reactant with a stoichiometric coefficient, like we have solved that question right now. Okay, so we can write this one. Okay, and we have also last class seen type of reaction: slow reaction, fast reaction, moderate reaction, with some example. So these are the we have discussed last class. ठीक है, तो अभी हम क्या करेंगे? Let's see based on this concept what are the new things today we are going to discuss. ठीक है, so I hope everyone you go through last class concept. Okay, so let's continue today's class. Do you have any doubt from the last class? Just let me know. Within 5 minutes we can discuss that one, or we are good to go. सब सही है ना? Shall we continue? कोई yes no कर दो so that we can continue. Okay. ठीक है, then we good to go. ठीक. So today we are going to discuss about rate law, unit of rate constant, elementary and complex reaction and molecular reactions. Don't worry, एक के बाद एक we will discuss each term. Okay, so last class we have write rate of any reaction in the term of reactant product. Okay, by suppose we have this one A to A convert into B to B. For this one we can write rate equal to 1 by A minus, because it's reactant, dA by dt, ठीक ना, equal to 1 by B dV by dt. So these are the things we have discussed. So last class we have seen rate can be correlate with reactant and product. Okay, so this rate law only relate rate of the reaction the term of reactant only. Reactant कोई लेगा, not other thing. Okay, so don't worry, we will discuss one by one. Okay. So rate law. So let's discuss. Okay, in between अगर किसी को कुछ डाउट हो ना, just let me know. ठीक है ना, अगर किसी को कोई डाउट हो, just let me know. ठीक है ना? Because I am assuming everyone you understood and I am clearly visible and audible. ठीक है ना? So rate law state that rate of any reaction that is direct proportional to concentration of the reactant with some power. With some power. What do you mean by that one? Suppose we have this reaction in which we have A mole of A react with B mole of B, and that is give us C mole of C and D mole of D. ये हमारा कोई simple सा reaction है. Okay. So how to write rate law for this one? Rate law for this one. So from the definition, rate law we state that whatever the rate of this particular reaction, that is direct proportional to some power of X of B. Sorry, A, because we have reactant A and B now. So we are writing this rate with term of reactant only. Okay. So let's A have some power X and B have some power Y. So that is direct proportional to rate. So if we remove proportionality constant, so if we remove this proportionality, we have to put some constant. Okay, like in mathematics, in other classes we will discuss. Suppose we have like this, X is direct proportional to Y. So to remove this proportionality, we just put some constant, suppose some constant T and Y. Okay, like that. So this is some constant. Likewise, that rate is equal to K, some power of A and some power of B, and that is X and Y. Okay. After that, this constant is called rate constant. Okay, rate constant, and that is depend upon two factor. वो किस पे depend करेगा? That is depend upon the reaction, ठीक है, and the temperature. That means what? If you change the temperature, this K will change. Okay, but at any particular temperature pressure, it will not change. It will not change. Okay, and it will vary also different type of reaction. Okay, suppose you are taking same type of reactant. Okay, but same type of reactant, or suppose you are changing the condition, in that case also rate will vary. वो rate वो vary करेगा. ठीक है. So just remember, rate constant depend upon two things. One is reaction and another one is temperature. अगर तुम different type of reaction लोगे, they have different value of K. Different value of K. ठीक है. I hope you understood this one. Do you have any doubt from here? Just let me know. Simple size में क्या है? We are writing rate law for this reaction in which rate is proportional to this some power of concentration, and we are writing this like this. ठीक है. And after removing proportional constant, we put K. ये हो गया. And we are also discussing this rate constant depend upon reaction, type of reaction, and the temperature. ठीक है. After that, let's see. Okay. So this one. So we can say what is the order of this reaction. Okay, suppose we have this is reaction, and for this reaction we can write rate equal to this one. Okay, H1 or any value, H1 or any value like 1, 2, 3, 4, anything, but those are number. Okay, so suppose we have this one, so we can write like this also: A to the power 2, B to the power 3. These are some number, whole number, any value, fraction. You can take fraction, whole number. These are some numbers, or we can say A to the power some power. Those are numbers. ठीक है. You understood this? Gen assembly understood ना? Okay, don't worry. While we'll solving this one, some numerically you will come to know what are X and Y. Those are numbers only. ठीक है. Suppose we have like this. We have some reaction in which we have writing like this: rate equal to K, A to the power 3 and B to the power 0.5. Sorry. B to the power 0.5, B to the power 0.5. So that means what? Order of this reaction with respect to A is 3, and with respect to B, that is 0.5. अरे वो mathematics में you are studying ना, what is the order of this equation? ठीक है, degree of this reaction. Like that in chemistry also, for any particular rate we have order. Okay, so here we can say order of this reaction with respect to A is X है, ठीक है. And B with respect to B, order is Y. Order is Y. Okay, now what is the order of this whole reaction? ये तो जो order है with respect to A and B है. Okay, so if you want to find out overall order of this reaction, then we can say that is X plus Y, summation of X plus Y. जैसे for example, if I ask you what is the order of this reaction in which we have rate equal to K, A to the power 3, B to the power 0.5, तो उसमें हम क्या लिखेंगे? उसका क्या होगा order? Order become, हम क्या करेंगे? Order of this reaction for this one we can write 3 plus 0.5, that is equal to 3.5. Okay, for this rate order is 3.5. Order is 3.5. Just add them, whatever the value you are taking, add them. Okay, so X can be anything, fraction, 0, whole number, like that. Okay, but don't take imaginary number. ठीक है. I hope you understood this one. Simple and sweet concept. Everyone understood, na? Okay. So let's proceed. So like we have discussed, suppose we are given any rate, we can find out the order. So what about any valence equation? Like, can we find out? So can we find out order of this reaction by merely looking at this one? हमको देख के पता कर सकते हैं क्या? For this one, rate is this much. So let's discuss this one. Okay, so this is our one balance equation. You can see we have balanced one. Okay, for oxygen to nitrogen, so balanced one. Okay, so order of any reaction we cannot tell by looking at this stoichiometric equation, balanced stoichiometric equation. Okay, but those are experimental value. Experimentally, they are varying the concentration of NO or O2, and based on this, they write one rate law. Okay, rate law. So we cannot predict that one. Okay, those are experimental value. Experimental value. Okay, everyone understood, na? Everyone understood this? So whatever the order, you cannot find out by looking at this one. Okay, those are experimental value. Those are experimental value. Okay. So let's see how much you've understood. How much you've understood. So let's solve one simple question. Okay, simple question. So everyone try this. इसको सब try करो. Everyone. Try this and you can write in the chat. Or just try this one. We will discuss this. Okay, so I'm giving you 1 minute. So everyone. Okay, so let me read the question. The conversion of X into Y. So X is converted into Y. Okay, and the follow the second order kinetics. Second order kinetics. The order of this reaction is 2. If the concentration of X is increased to 3 times, how will it affect the rate of formation of Y? ठीक है, मतलब जो rate होगा ना, rate means speed, how it will affect. Okay, how it will affect. Okay, so to understand this one, so let write the rate law for this one. Rate law for this one. Let's, so in this equation we have given X is converted into Y. X converted to Y or I. So if we want to write the rate law for this one, we can write rate equal to some constant K, okay, reaction constant, and X to the power X with some power. ठीक है, और किसको पावर लेंगे? It is given second order kinetics. Second order kinetics. Okay, okay, Parveen, thank you. Okay, second order kinetics. That means what? We have to put 2 here. Order of this reaction is 2. Okay, so this is the data we can get from this one. After that, it states that X increased to 3 times. So whatever the X, it is converted into 3X. Its concentration is changed into 3X. So let's see what is the new rate of the reaction. Okay, so initially we can write R equal to K X to the power 2. Okay, so let me see. Correct. Gen B. Okay, correct. I don't. Okay, correct. Like some of you have answered me this correctly. Correct. Okay, so let's discuss this one for others who don't get this one. Okay, this one. So let's take, we have this rate constant changed to R dash, new rate. And I told you for any reaction at particular temperature, pressure, K will not change. So this is remain K. But our X change into 3X. Change into 3X to the power 2. So this can be written K 9 X to the power whole square. Okay, so this is our equation 1 and this is our equation 2. Okay, so to get the relation between R and R dash, just divide them so that K will cancel out and X to the power 2 will cancel out. So if we divide this one, we'll get R by R prime equal to, initially we have K X to the power whole square. Okay, but this K 9. This is X whole square. Okay, so now we can cancel them, right? K and K, just cancel them. Then you will have 1 by 9. So we can write 9 multiply R equal to R prime. So whatever the new concentration or rate of the reaction we got, that is 9 times the initial value. So we can say it is like increasing with 9 times. Okay, 9 times. So everyone understood this, how to solve this type of problem. Okay, like this type of problem given to us. Everyone understood this? So what we did, we abstract the data from this one. So here we are given second order. So we write the rate law R equal to K x to the power whole square because second order. After that is given, this x is tending to 3x, like thrice. So we put those value. After that, we find out the new rate. We divide these two equations to get the relation between R and R prime, and we got that is 9 multiply initial rate of the reaction equal to new rate of the reaction. Everyone understood this? समझ में है ना सभी को? So shall we proceed? हम आगे बढ़े? Anyone can just let me know. Okay. ठीक है. So let's proceed. Okay. Simple है. Okay. After that, so suppose I told you na, so this rate of reaction, those are not those are experimental value. So how they got the relation between those? Okay, like how they're writing the rate law. Suppose we have some reaction which consists of reactant A and B, and reaction is taking place. Okay, and different time. Okay, at different time they measure the concentration. Okay, I mean this. Suppose we have a reaction in which the reactant are A and B. While the react, when we are taking concentration of A 0.2 and B 0.3, we get rate of the reaction this much. Okay, and this data, like if you take 0.2 and 0.1, we get the rate of reaction this much. And if we take 0.4 of A and 0.05 of B, at that time we get rate of the reaction 1.43 into -4. So based on this data, can you find out what is the rate of the reaction with respect to A and B? Can you find out this one? So everyone please try. After that I will discuss. Like we will discuss this one. Everyone try this. At least read the question. Try to analyze. Like if you are given this type of data, how to solve them. Okay. Everyone done? सभी ने किया? Okay. So let me solve this for you. Just carefully see me so that you can solve this type of problem later. Okay. Let's solve this one. So because we need to find out order of this reaction with respect to A and B, that means what? We have to write rate law for this reaction. Ki how this rate relate to A and B. Okay. For that one, we can write like this. So you know this from rate law, rate can be written K A to the power X, B to the Y. So here we need to find out X and Y so that we can tell what is the order of with the order of the reaction with respect to A and B. If we somehow find out X and Y value. Okay. So what we will do? Okay. So from that here you can see we have given rate, concentration of B and concentration of A. So what we will do? We put those value. Okay, and based on this, we can find out X and Y. So see this one. So first take this first value. Concentration of A is 0.2 and concentration of B is 0.3. Okay, and these are some power X and Y. And at the time rate is this one. This is the first equation. For second equation, I take this value. I simply put those value of A, B, and R naught in this equation. Okay, everyone understood this? Now, how to use these two equations? You have this one, and this one. They have same value. So what we'll do? If we divide them, they cancel out, and we are left with Y. इसलिए हम क्या करेंगे? Divide करेंगे, not multiply. So let's divide them. If we divide them, what we will get? If we divide 1 and 2, we divide them. So these are same value. No, these cancel out. These will cancel out, and you get 1. And these value is the same, so we'll cancel them and you get this one. ठीक है? तो इसको हमें कैसे मिला? जैसे होता है ना, suppose you are having this A to the power 2, ठीक है, and B to the power 2. So we can write A by B power 2. अगर power same है, so we can put in between. Same लिख सकते हैं. So actually this is 0.3 divided by 0.1 to the power Y. So ये 3 to the power Y आ गया. ठीक है? Now what is the value of Y? We know this something to the power 0 equal to 1. That means what? If you take Y equal to 0, you will get this relation equal. ठीक है, so y equal to 0, we got y equal to 0. Everyone understood now how I get y equal to 0? Like anything to the power 0. जैसे suppose you have x, no, let's don't take x. Okay, suppose we have L to the power 0, that is 1. Anything to the power 0, 1, that is y equal to, we get 0. Y equal to 0. Okay, so to get the value of x, so let's take other relation. So for that one, I am taking this one. This first one only, because now we come to know y equal to 0. So y equal to 0. In the first equation, in this one, I put y equal to 0. After that, I take this relation. I take this one, this relation. A equal to 0.4 and B equal to 0.05, and rate of the reaction is 1.43 10 to the power minus 4. I have taken, and we have already find out y equal to 0. So I put y equal to 0 here. So y, so that means this value 0.32 by 0 equal to 1, and this also 0.05 to the power 0 equal to 1. Okay, so they cancel out. Sorry, the value is 1. So we can now divide them. So now we can get this one divided by this. We will get this one. We approximate this equal to 5. ठीक है ना? 5.05 approximate equal to 5. ठीक है, and this one equal to 1.43 na, and we have here 0.5. So if we divide this one, you will get 5 by 14.3. This much you will get. Okay, this much you will get, and right side 2 by 4 to the power x. 2 by 4 equal to 1 by 4. Okay, so from here we can get x equal to 3 by 2. Everyone understood this? What we did, we get the value of y. We just put that value here, and after that we divide this equation 3 and 4. We get this one. So x is equal to 3. So from here we get y equal to 0 and x equal to 3 by 2. So from here we can tell order with respect to A is 3 by 2, because x equal to 3 by 2. X equal to 3 by 2. So with respect to A, the order is 3 by 2. With respect to B, order is 0. So everyone understood this, how to solve this type of problem. Okay, and what is the method? How to find out order? So can you tell me what is the order of this reaction, overall this reaction? Can you tell me? Yeah, correct. This is 3 by 2 plus 0, that is 3 by 2. So overall order of this reaction is 3 by 2. 3 by 2. Okay. So shall we proceed? हम आगे बढ़े फिर? I hope you understood this one. अभी देखते हैं what is the rate of this or unit of rate constant. Okay, we have that proportionality constant ना, rate constant. तो उसका unit क्या हो? How to find out unit of that one? Okay, so let's see. Okay, suppose for example, you are given this one. A simple सा दिया गया है, एक कोई इक्वेशन है. इसे दिया गया, सपोज फॉर एग्जांपल ऐसा है, म्यू वेलोसिटी पर डिस्टेंस, एंड यू आर आस्क्ड व्हाट इज द यूनिट ऑफ दिस टर्म. ये जो म्यू है ना, व्हाट इज द यूनिट ऑफ दिस वन. सो हाउ यू आर डूइंग, हम कैसे करते हैं, एंड यू आर गिवन दिस टाउ है ना, दैट इज ये गिवन है स्ट्रेस, एंड दिस इज v is velocity and L is length. So like, can you find out unit of this mu using this one? Yes, we can find out. So what we are doing, हम क्या करेंगे, to find out the unit of this mu. So we put this mu एक साइड हम रखेंगे, फिर इनका हमेशा करेंगे ये L by V. After that put unit of each term. ये stress का put कर लो, length का put कर लो, velocity का put कर लो, you will get the unit of this one. ठीक है. So similarly, let's find out what is the unit of rate constant. कोई unknown equation suppose you are given, you can easily find out. So to find out unit of rate, what we will do, suppose this is the equation given to us. ठीक है, ये हमारा जो equation है, that is given to us. Okay, this one, and rate, for this one rate we can write like this. Now we need to find out what is the unit of k. जैसे होता है ना, what is the unit of time, that is second. What is the unit of length, that is meter. ठीक है, and what is the unit of mass, that is kg. So likewise that we have to find out what is the unit of that rate constant. So let's find out. उसका यूनिट क्या होगा. Okay, so now we can write rate equal to k a to the power x b to the power y. After that, rearrange this one. If we because we need to find out rate unit of this one, so keep this one because it's equal to sign. So whatever the unit of this rate divided by this one, that is equal to k. So if we can find out rate of this rate, or we can say unit of this right side part, that is equal to left side part. Okay, so let's find out this one. ठीक ना. So we know this rate of reaction. Rate of reaction means what? Concentration with respect to time. So you can say mole per liter per second. That is the unit of rate. After that, we can write this. This is these two are reactant. So we can write concentration of reactant equal to x plus y. Okay, x plus y. So this is the concentration of reactant. Okay, so unit of this reactant, that is all concentration, and that is we can write mole per liter, and that is x plus y. Take x plus y, and we know this x plus y is the order of the reaction, that is denoted by n. Denoted by n. That means what? Here we can write. Here you can see mole per liter per second. ठीक है, divided by mole per liter to the power n. तुम क्या करेंगे? टेक दिस n अपसाइड. ठीक है, तो तुम्हारा क्या होगा? सो हियर वी कैन राइट मोल पर लिटर पावर 1 minus n. 1 minus n. जैसे फॉर एग्जांपल यू आर हैविंग दिस a divided by a to the power n. So how we can write this one? a पावर ऑफ, इसमें a का पावर कितना 1 है, नीचे n है, so we can write 1 minus n. And suppose we are like this one, a multiply a to the power n, so we can write a 1 plus n. In the case of multiplication, add them. In the case of division, subtract them. ठीक है, so we can got this one. So now if we varying the value of n, जैसे हम n का वैल्यू वेरी करेंगे, we can find out different unit of k, different unit of k for different order of the reaction. ठीक है, order of the reaction. Everyone understood this? ये सभी को समझ में आया क्या? Or do you have any doubt? So shall I repeat this one, or it's okay? Everyone just let me know. Okay, so let's proceed. ठीक है, ये सिंपल सा है. ऊपर भी मोल पर लीटर पर सेकेंड एंड बिलो ऑल्सो मोल पर लीटर. ओके, नॉट सेकेंड. ओके, दैट इज वाई ये सेकेंड अपने आप रहे. ठीक है. After that, let's find out unit of different order of the reaction. First order, zero order, second order, third order, like that. ठीक ना. So for zero order, just put value of n equal to 0. In that case, what you will get? Unit of k, there is mole per liter. ठीक है, mole per liter. यहाँ में मिलेगा mole per liter. ठीक. And if you take first order reaction, just put n equal to 1. So 1 minus 1, that is 0. So ये वाला term पूरा 1 हो जाएगा, and you will have per second. It's the unit of k for first order. And for second order, just put the value of n equal to 2. You will get this one, mole per liter per second. That is for second order. देखो, you can see the difference ना. इसमें क्या है? मोल पर लीटर पर सेकेंड, इसमें है लीटर पर मोल पर सेकेंड. ठीक है ना. So this is the difference. And like I think you can find out same thing for third, fourth, fifth. कोई भी ऑर्डर के लिए you can easily find out. ठीक है ना, you can easily find out. So now can you tell me what is the order of fifth order? Fifth order reaction. Can you tell me unit of that k? Everyone please try to solve this. क्या होगा इसका? Everyone for fifth order. तो क्या होगा? Just put the value of n equal to 5. N equal to 5. So what we will get? Mole per liter. 1 minus 5 equal to minus 4 per second. So we can write mole and liter 4 per second minus 1. This is the unit of k for fifth order. ठीक है, fifth order. Everyone understood this? I hope you understood. Just change the value of n for different order and you get the unit of k. Easily आपको मिलता जाएगा. Okay. So everyone you understood this? or do you have any doubt, or shall I repeat? Okay, I hope you understood this. Okay, so let's for the second, मतलब next. इसको थोड़ा सा ट्राई करो everyone. Please try this. Try this and you can like answer in the chat. Everyone do this. Okay, so let's solve this one. Let's solve this one. Okay, so the question is correct. Parveen, you are answering this for first one or second one? Parveen, I hope this is for second one. Correct. Yeah, correct. Okay, so let's solve this one. Okay, let's solve this one. So before that one, so what we'll do? So let's write this general formula for this one. So for K, we can write a unit is mole per liter. ठीक है ना? 1 minus n per second. So that we can compare these two unit, right? So here we can write. So here we are given mole to the per half, liter per half. So we can write mole. वो तो उसमें कैपिटल एल ले रहा है, उसमें स्मॉल एल है, सो डोंट वरी. सो मोल पर लिटर, ठीक है, एंड ब्रैकेट half. I'm taking half, so that if you take the half in between within the bracket, you will get mole to the per half and L to the minus half and per second. So if we compare this one, then we can come to know कि तुम्हारा जो ये वैल्यू होगा, this half is equal to 1 minus n. So we can write half equal to 1 minus n. And if you solve for n, then you will get 1 minus 1 by 2, that is equal to 1 by 2. So for this one, so this is one is your half order reaction. So half order reaction. Okay. So likewise that, let's find out for this one. For this one, ये कितने order का? ठीक है. For this one also, just rearrange this one. So just try to remove this, bring this half outside the bracket. So what we'll do, mole per liter ऐसा है. So half per second per half. ठीक है. So we can write like this one, mole per liter, ठीक है ना, minus half, minus 1 equal to half equal to minus 1. So we can write this one is mole per liter minus half equal to this one. अरे ये ऐसा था ना, this is mole, this is per mole per. Okay, like so for example, we are given A by B. This can be written B by A to the power minus 1. अगर आप minus 1 power लेते हो, that will flip. Okay, so here actually liter per mole. So this is our liter per mole. ठीक है, ये जो है तुम्हारा this one, ये तुम्हारा है liter per mole, and I want to write this in the term mole per liter. So what will do? What I will do? I can write mole per liter और कर देते हैं power minus 1. ठीक है, ये ऐसा हो गया. And here we have minus 1 and outside is half. So I multiply that one and overall I will get minus half. Everyone understood this? How I rearrange this one? मैंने कैसे किया? So from here we can find out whatever this half value. If you compare this one with respect to the standard equation, then we can come to know 1 minus n equal to minus half. ठीक है, तो हम इसको क्या लिख सकते हैं, n equal to 1 plus 1 by 2, or we can write this is equal to 3 by 2. So for the second one is 3 by 2 order or 1.5 order reaction. सभी को समझ में आया? और डू यू हैव एनी डाउट? सभी को समझ में आया क्या? और डू यू हैव एनी डाउट सो दैट वी कैन डिस्कस? आई होप एवरीवन अंडरस्टूड दिस. The main thing is, okay, we need to write this in the term of mole per liter, not in other term. Why we writing like this? So that we can compare this one with respect to the standard equation. इसलिए हमने ऐसा किया. Okay, and how we did this? We know this identity. हमें ये identity पता है. If we put something to the power -1, then will flip. वो उलट जाएगा. ठीक है? And from here we get 3/2. I hope everyone understood this. ठीक है? तो चलिए हम आगे बढ़ते हैं. ठीक है? आई होप एवरीवन यू अंडरस्टूड दिस. अगर आपको फिर भी इफ यू हैव एनी डाउट जस्ट लेट मी नो, वी कैन डिस्कस. ठीक है ना? ठीक है, अभी हम देखते हैं what is elementary reaction and what is complex reaction. Perhaps you have heard of this two terms, elementary reaction, complex reaction. And suppose you are going through any organic reaction or any other chapter also, perhaps you heard of them. Okay, so let them discuss one by one, like which type of reaction is called elementary reaction and which one is called complex reaction. Complex reaction. And suppose you have studying this one, this first chapter of this organic of 12, the haloalkane haloarenes. There you have studied this how to find out order of the reaction, or order of the reaction, we can say slow step of any particular reaction, and how that is related to this complex reaction and elementary reaction. Let's see. तो उससे पहले हम डिस्कस करते हैं कि what is elementary reaction and what is complex reaction. ठीक है ना? So let's see one by one. Okay. For example, we are given this equation. ये हमें equation given है. This is to how to identify whether the particular reaction is elementary reaction or not. Elementary reaction or not. ठीक है? Any reaction which is taking place in the single step. Single step, na, that is called elementary reaction. Elementary reaction. And I will tell you which are the reaction they are taking in multiple step. Okay, so don't worry. So elementary reaction means any reaction which is taking part in the single step. एक step में निपट गया, so that is called elementary reaction. ठीक है? And you can see this one. Directly hydrogen is react with oxygen and it will give us water. This is simple, sweet, single step process, and that is called elementary reaction. Elementary reaction in which we have only one is okay. Or here we can say, if we want to find out order of this reaction, just remember, for any elementary reaction which is taking place in single step, those are called elementary reaction. For those type of reaction, order is sum of the stoichiometry of the reactant. ठीक है? तो अभी मुझे बताओ what is the order of this reaction? That is 2 + 1 3. ठीक है? order इतना है. ठीक है? ठीक है? So now let's see. So everyone understood the order. What is the order of this elementary reaction? So whatever the number of reactant within this reactant, those are called order of the reaction. ठीक है? And अगर if any reaction taking place in more than one step, अगर ज्यादा step है, those are called complex reaction. For example, like here you can see HBr react with oxygen and give you water and bromine. ये तुम्हें ये product देता है. So अगर if you look at this one, you think this is a single step reaction. This may be unitary, like elementary reaction, but this is not a elementary reaction. Why? This is not a elementary reaction. Let's see. To get this product, H2 and Vr2, HBr and oxygen react with this different step. First, what we'll do, 1 mole of HBr react with oxygen and it will give you HO2Br. After this HO2Br react with 1 mole of HBr and it will give you 2 mole of HOBr. फिर ये react करेगा ऐसे and finally you will get this. So we can say this particular reaction, it consists of 3 steps. That is why this type of reaction is called complex reaction. ये elementary नहीं है because it consists of 3 steps. 1, 2, 3. So this is why this is called complex reaction. ये समझ में आया? Now, like how to find out order of this reaction. Suppose any reaction which is taking part in different steps, for them we have different method. Okay. So this each step is called elementary. ये सभी हमारे elementary reaction है, and they combinedly they form complex reaction. complex reaction. And if you want to find out order of this complex reaction, in that case you have to take the slowest step, which is the rate determining step, and that will give you the what I can say, order of the reaction. For example, for this reaction, suppose suppose this is the slowest step. In that case, order of this one is 1 + 1 2, and if suppose this is the order of the reaction. Okay, so you have to first find out slowest step, and if you figuring out which is the slowest step, then you can easily find out the order of the reaction. Okay, you everyone understood this? How to identify which is the elementary reaction, which is the complex reaction, and how to find out order of the elementary reaction and complex reaction. Everyone understood this? Or do you have any doubt? Just let me know. Or shall we proceed? I hope we are good to go. आगे बढ़े फिर? ठीक है, let's proceed. Okay. So based on the molecularity, we have different type of reaction. Okay. So what is molecularity? Let's understand what is molecularity. Molecularity means number of reactant molecule, that those may be molecule, atom, and ions. Okay. Who is taking part of the chemical reaction and they collide to form the product. I mean, whatever the number of reactant you are taking, all the reactant will not give you the product. Those reactant will give you product which say collide perfectly. Okay, perfectly, and those are called molecularity. For example, suppose you are taking 5 mole of A, which react with 3 mole of B. It may be possible, like not all the air two mole of B and give you some product. So in this case, we can say molecularity of this reaction is 2 + 2. Okay, this is the molecularity of the reaction. Molecularity is simple, the number of atom that those are taking part in the product formation, that is molecularity. Okay, molecularity. For example, if you are taking this one, for example, for this one, PCl3 is converted into PCl3 plus Cl2. So this is one atom or one molecule is converted into PCl3 and Cl2. That is why we can say this unimolecular, because in here only one molecule is taking part in the chemical reaction. Okay, or molecularity means number of reactant particles which are actually taking part in the product formation. Reaction में नहीं, product formation. Which is called molecularity. So this is unimolecular because one molecule is taking part in the chemical reaction. वैसे ही these are okay. Here you can see we have two molecules which are taking part in the chemical reaction. देखो, here they collide and give you the product. So that is why this is called bimolecular. Here we have trimolecular. Okay, trimolecular. So after that, if we increasing the number of atom, okay. So now, can you tell me what is the molecularity of this one? Okay, so like some of you are thinking, because we are taking 4 atom for product formation, it is possible the molecularity is 4. Okay, but remember, molecularity more than 3 is not that much effective or rare, we can say, because while there is collision, perfect collision is taking place within the 3 molecule only, 3 atom only, not more than that. That is why most of the time, or for most of the reaction, okay, molecularity is 3, because why you collide them, na? Only 3 can perfectly collide with each other and not more than that one. Okay, so that is why molecularity of 3 is very rare. ठीक है ना? And more than that is you will not get that much. ये everyone you understood ना? यहाँ तक सभी को समझ में आया क्या? जैसे if we sing about this summary, so these are the things today we are discussing. So initially what we have did, how we writing the rate law in the term of concentration of reactant with some power x and y, and to get, or we can tell rate of the reaction with respect to A is x and with respect to B, that is y. ठीक है. Elementary reaction are those in which are taking place with a single step. Okay, and complex reaction are occur in more than one step. ठीक. After that, to find out this rate of this reaction, we need to find out which is the slowest step, and that will give us order of that complex reaction. Okay, and what is molecularity? Molecularity is the number of atoms which collide perfectly to get us the product. Okay, in any elementary reaction. Okay, that is molecularity. Okay, and molecularity greater than 3 is rare, because we already discussed perfectly collision for atom more than 3 is rare. That is why at most the molecularity is 3. Okay, so above that one is not that much possible. Everyone understood this? ये सभी को समझ में आया क्या everyone? Or do you have any doubt? Okay, so after that next class we'll discuss integrated rate law. Next class आगे जो class होगा, but this is the thing for today's class. Do you have any doubt, anyone? Okay, so today please everyone go through the NCERT book, try to solve some question up to this concept. Okay, and just let me know tomorrow. Okay, so these are the thing from my side. If you have any doubt from any concept till we have discussed, just let me know, we can discuss. Okay, and perhaps we have another class also. 2 minute बचा है, बताओ. Oh, it's fine. Okay, अगर if you don't have any doubt, just give me a thumbs up. ठीक है, and you can leave the class. और इसी में कंटिन्यू करते हैं क्या तुम लोग? Okay, so I'm stopping this one. So बताओ ये. Okay, so I hope you don't have any issue. Okay, so give me a thumbs up and you can leave. Okay, ठीक है फिर. Bye everyone. I'm ending this now.